Hello students, in this video we are given this RL series circuit and a sinusoidal input voltage is applied here with phase shift phi. It is given that when this source is applied to the circuit, then at that time phi is equals to 0. So we know that at t is equals to 0, this source is applied to the circuit or this switch is closed. At that time phi is also equal to 0. So first we will find what happens at t less than 0. What is the status of circuit? This signal is not applied to the circuit and this will behave as an open circuit. So no current will flow at time t is equals to 0 minus time, and the same current will be flowing there because of the status of this inductor. It doesn't change immediately. At t is equals to 0 minus and at t is equals to 0 plus, it will remain same and it is equals to 0 ampere. Or we can say that voltage is also 0 because t is 0, phi is 0, so V0 is also 0. So there is no current at time t is equals to 0. So here we can write that I0 is equals to 0 ampere. Okay. This data we will use in finding the value of K while we will determine this expression for IT. Now write KVL equation at time t greater than 0. Okay, when switch is closed and this voltage is connected and the value of voltage is 150 sine 500 t plus phi, that is equals to drop across resistance plus drop across inductance. Now put the values R and L, that is 50 and 0.2. Now make this coefficient 1, divide every term by this 0.2. So our equation will become, this will become 750 and this will become 250. So this is our differential equation, linear differential equation. Now compare this linear differential equation with our standard differential equation. So here P is equals to 250 and Q is equals to 750 sine 500t plus phi. Okay, we know the solution of this differential equation. Solution is IT is equals to e to the power minus pt integration e to the power plus pt multiplied by this q, integrate with respect to t, plus k e to the power minus pt. This is the solution of this general differential equation, and substituting the values of p and q, we can get the solution of differential equation that we derived after writing KVL. So here IT is equals to e to the power minus 250t e to the power plus 250t. Q is 750 sine 500t plus phi plus k e to the power minus 250t. So this is our equation, transient current equation. Now we will simplify this by integrating this term, combination of this term, and we know that integration of e to the power, we know that integration of e to the power at into sine bt with respect to t is e to the power at divided by a square plus b square a sine bt minus b cos bt. Okay, so substitute the values, we can get the value of it. Write down this as it is, e to the power minus 250t. Now write down the integration by this formula, e to the power, this is minus, this is plus, divided by 250 square plus 500 square. A is 250 sine 500t plus 5. Yes, note that here whole angle will come here, 500t plus 5 minus b is 500, the complete angle is 500t plus 5, and the last term is k e to the power minus 250t. Now we will simplify this. This will become 1 and divide these two terms by square of their coefficients, sum of square of coefficients in root by this term plus 500 square. Why we have divided these two by the squares and root and sum of them, so that we can introduce a phase shift theta here. So here, since we divided by this, multiply by the same number, that is 250 square plus 500 square. This will be cancelled and root will come here. What is the value of this root? This value of this root is 559. Yes, there is 750 is also there. Okay, this 750 is also there. So 750 divided by 559 is equals to 1.342. Now we can replace this with cosine of theta, because sine is already there, so we can apply the identity sine A cos B. Write down this term here. This is 1.342 plus k e to the power minus 250t. This is our it. Okay. Yes, this is cos theta and this is sin theta. Now we will replace this with cos theta to make it a identity. 250 square, you can also replace it with sin theta, but then a different identity will appear there. This is 500 divided by this number 250 plus 500 square. Okay, from here we can get the value of tan theta, and that is equals to 500 by 250. So here we can get theta is equals to tan inverse 2, and that is equals to 63.43 degree. Okay, from here we got the value of theta, and that is 63.43 degree. Now replace this with cos theta. This is cos theta and this is sin theta. Now I apply the identity, that is sin A cos B minus cos A sin B. That is sin 500t plus phi minus theta. Okay, this we got. Write down this as it is, this as it is, this as it is. Okay, so this is the value where theta is 63.43 degree. Now we will find this value with the help of current at time t is equals to 0. We know the current at time t is equals to 0 is 0 ampere. So at t is equals to 0, I0 is 0 ampere. Substitute in the equation. This is 0, k e to the power 0 plus 1.342 sine, this will become 0 plus sine phi minus 63.43. Yes, what about this phi? We know that at t is equals to 0, phi is also 0. It is given. So here find the value of sine 63.43 minus. So here k minus 1.342 sine of this value 63.43 is nothing but minus 0.89. This is the value of sine. So here k comes equal to this multiplied by this is equals to 1.2. So substitute this value here, that is 1.2, and we got the IT expression for this IT. So this is our desired expression IT. We got this value of k with the help of the current at time t is equals to 0. So this is the way to solve such type of questions. Thank you.